Hi everyone, I'm so happy to share my experience on how to build a data pipeline for conversation logs and retrieve information for analytical purpose. Well, actually the theme of this presentation might be more data engineering things than the data science thing like what Shubhanshu and Sylvia's presentation, but I hope you enjoy this presentation. So before we begin, let me introduce myself. I'm Dewi Oktaviani. I got my master degree from Waseda University on 2017, and currently I'm working as a data engineer for 2 years in Kata.ai. In a day-to-day, I'm responsible to manage Spark job for ETL process for the conversation logs behind the client's chatbot, and then manage active scheduler on Airflow, and then write queries for reporting and so many data engineering jobs. Feel free to contact me on my GitHub and LinkedIn account. Okay, let me explain a little description about what Kata.ai do. So in general, we provide a conversational AI for better customer experience. We have many products, but our main product is a web platform that enables you to create a bot with almost no code implementations. And then we can predict sentence and train the model with training data that you want the bot to understand on this Kata platform. And the last is we can deploy the bot to multiple channels that are available in Kata platform without worrying the API for each messaging channels. So once the bot is successfully deployed, the bot will respond accordingly to our customer. As the company grow up and the pandemic hit, we handle more and more clients coming from the especially public sectors because since the social restrictions happen in Indonesia, those makes the conversational data grows rapidly. So now we handle more than 750 million rows of conversations, and more millions data are coming every single day. Here comes the challenge on how to build a data pipeline to handle the growing conversational logs, and how to process the data and give valuable insight for the both owners, business analysts, or the stakeholders. Let's say we create and deploy a bot in Kata platform. So I think it's normal for us as the bot owners that we want to know how many users are interact with our bot and what kind of interactions that happen between our bot and customers, and about the time when it happens and so on. And those are what the data engineer's responsibility to sort out problems and bring the solutions. But first thing first, we have to explore how the conversation logs are processed by our microservices. Okay, this diagram describes how conversations are processed by our microservice. This all started when there are incoming messages from any messaging channels such as WhatsApp, Telegram, Line, and so on coming into our system. And then our webhook service parse and serialize the message into a schema that understandable by our microservices. Webhook service then publish the serialized message to RabbitMQ as the message broker. Here, message broker is important because it will requeue and resend messages whenever the destination service are unreachable. It will also guarantee that message sent between services are delivered orderly. The message broker delivers message to dialog engine service. This service and then forwards the message to an LU service for intent classification and entity extraction. An LU service will chunk down the message, extract the entity, predict intent, and then once the result is there, the result then sent back to the dialog service engine. And then in dialog service engine, when it receives the result, the intent classification and the entities extraction, it will map the predefined reply message based on the intent and send back the reply message to the channels. And then those process makes the bot knows how to respond right based on the incoming message from the customer. And then the next important thing is how the strategies or how the steps to retain conversation logs on our data pipeline and utilize it for analysis. Okay, so we need to find out the steps required to build a system that can retain conversation logs. First, we need the temporary message to retain the streaming data. And then second, we need the framework that can do extraction, load, and transform the streaming data transfer. The streaming data faster. Sorry. And then the third, we need a distributed file system that can support the processing data. And then the fourth, we need an OLAP or online analytical purpose database to support analytical report. And the last, we need automation tools to chain all the process. Yeah, all those chain steps that I explained before is what the definition of data pipeline is. So the data pipeline is a set of tools and processes used to automate the movement and transformation of data between a source system and a target repository. Here, I think it's me and other data engineer who trying to pull and connect the pipe so that the data can pass through from certain sources to the target destinations. These diagrams show how the conversation logs are processed. And in order to retain the conversation logs, we need to create additional service that listen to the incoming messages from RabbitMQ. And then let's go to the first step to store conversation logs. We need to implement a message log to temporarily store the data. Okay, the one previously mentioned before, that those additional service is a parser service that listen to RabbitMQ, which parse the messages and add event time and then publish the message to Kafka. Apache Kafka here is a distributed event platform that capable of handle trillions of streaming message and persist it on disk for a certain time. And then now we have our streaming conversation logs stored in Apache Kafka. Then what is the next step? Okay, let's explain the number 2 until number 5 in one go. Okay, here we use Apache Spark as the in-memory processing, which means all the transformation process is done in memory, not in disk. That's why Spark operation can process streaming data faster. We run a Spark code to read the stream messages from a Kafka topic. And then we select only columns that we need and then add datemestamp partitions, and then write the transform data stream to Google Cloud Storage in a Parquet format. Anyway, we run multiple big data tools here, such as Apache Kafka, Apache Spark, Apache Airflow, Hive, Trino on Google Kubernetes engine. And we use Google Cloud Storage to store the Parquet files. And then we store the conversation logs in a Parquet format. Parquet format is a data binary files in a columnar storage format. Why is it columnar storage format? Because it supports faster query analytics. Columnar storage stores data in a columns rather than the rows that usually used by traditional databases. And then distributed file system is any file system that allows access to files from multiple hosts sharing via a computer network. Here we use a Hive metastore to support metadata storage for the parquet files. This metastore, this Hive metastore is used by Trino, or previously known as Presto, as the query engine. Then Trino will map the metadata information and the parquet files in the Google storage to discover the data in a table view. And the last, we use Airflow as a tool to scheduling the Spark job to run at a certain time in a day. So we can track the progress, logs, code, and trigger tasks and success status in the Airflow dashboard. And then once we have applied the data pipeline, we can curate the analytic results, such as here. This is the Wordcloud chart where display the most used sentences by user. But I think it shows Indonesian sentence like promo, hello. Yeah, I hope you understand. And then the next is this shows the peak hours that displays the most interactions happen between clients and bot. The darker color means the most interaction happen at that time. And then finally, here we come to the conclusions that there is no silver bullet in building a data pipeline. We should follow the company considerations and characteristics of each tools to make use the tools wisely. And then a reliable data pipeline will help business analysts and stakeholders to get insight efficiently. I think this is the last part of this presentation. Thank you for listening, and feel free to connect on my LinkedIn and GitHub. Thank you.
Thanks, Dewi. That was a really interesting presentation. I realized earlier on when you were showing how much interaction there is for the different days, Wednesday seems to be the one that has the most interaction. I'm wondering, is there a reason why?
Wednesday. Oh, yeah. I think at that time there were a message blast from the company. Maybe it's like a notification for the customer that a promo there are discount or promo happens.
I see. Thanks for answering that. Yeah, we have a question from Jeff. So Jeff asked whether there are any challenges faced when a timestamp value is stored in the particular time rather than conventional day, month, year format. If yes, how is that managed?
Where there are any challenges faced? Oh yeah, actually the timestamp value stored in parquet format. Why we use timestamp value in the parquet format? Actually, we use a certain so we have a partition date in a parquet format, which are used as the partition table to make the query faster. So we have a format like DD-MM-YYYY, but for the timestamp, we don't use timestamp as the partition date, but it is only for the information that the conversation event time happen at those timestamp value, something like that. Maybe yeah. I hope it answers.
Yep. Jeff, we hope that answers your question.
Yeah,
If
or
not, feel
maybe
free.
yeah. Maybe I can write the answers on the YouTube comment, or yeah, you can contact me.
Yep. Yeah, feel free to connect with Dewi via LinkedIn as well.